Today we start reversible reactions and dynamic equilibrium. So what is reversible reaction? In order to study about reversible reaction, we consider a chemical reaction in which A react with B and form products C and D. Here A and B are reactants, C and D are products. Those substances which combine with each other known as reactants, and those substances which are produced during chemical reaction or which are formed during chemical reaction are known as products. Here A react with B and form products C and D. A react with B in the forward direction and form products C and D. So this type of reaction is known as forward reaction. And here C react with D, it means products react with each other and form reactants again, A and B. Such type of reaction is known as reverse reaction. On the basis of forward reaction and reverse reaction, there are two other types of reactions which are known as reversible reaction and irreversible reactions. Irreversible reactions are those reactions in which products do not recombine again to form reactants. And these reactions, irreversible reactions, are represented by a single arrow which is directed from reactants towards the products. For example, when magnesium react with the hydrochloric acid, it forms magnesium chloride and hydrogen gas is produced. Here, magnesium is the member of second group, so it is very reactive metal. It reacts completely with the hydrochloric acid and form magnesium chloride and hydrogen gas is produced in this reaction. So reaction becomes stopped when all magnesium used during the reaction. So here reaction will only proceed in the forward direction. Such reactions are known as irreversible reactions because here magnesium chloride and hydrogen do not recombine to form magnesium and hydrochloric acid again. Magnesium is very reactive metal. It completely dissolves in hydrochloric acid. On the other hand, reversible reactions are those reactions in which products recombine again to form reactants. Such type of reactions are known as reversible reactions. And reversible reactions are represented by double half-headed arrows. This half-headed arrows is used for forward reaction and this half-headed arrows is used for the reverse reactions. For example, if we study the rate of decomposition of mercuric oxide HgO, then this mercuric oxide is heated in the test tube, in closed test tube, so that mercury, Hg and oxygen cannot escape during the chemical reaction from this test tube. So when this mercuric oxide is heated in the closed test tube, then it produces mercury Hg and oxygen O2. Hence, this test tube is closed, so mercury and oxygen again react with each other and form mercuric oxide again. Here, rate of decomposition proceed in forward direction, which is represented by this arrow, and rate of formation of HgO, mercuric oxide, takes place in the reverse reaction, which is represented by this arrow. Here, a time reaches when rate of decomposition of mercuric oxide becomes equal to rate of formation of mercuric oxide. This time is known as equilibrium. At equilibrium, the concentration of reactants and products must become constant. And here forward reaction must be equal to reverse reaction. It means that formation of mercuric oxide must be equal to decomposition of mercuric oxide. So this state is known as equilibrium state.